exo 5. Now this is exo 5 fish 3, and they're giving us a regular expression called L, and they're saying L is equal to B plus A B star. So they want us to construct the automaton minimum, so which means you must get the automaton and reduce it. So what I'm going to do, I'm going to say 8L equal, for example, S0. So I start deriving. So S0, you derive it by A. What are you getting now? This is a B plus, which means there must always be B's. And this simply means that strings in this language, L, can only start with B because you're having B plus, which means there must be at least one B. So when I try to derive by A, this is not start, that's why I'm not splitting it. And I said derive by A, they're saying they must start with B. So, and I'm saying I want to remove the first A, so there is no first A here. So what I do is, I say this is what? This is not accepted. It is that. Then I derive by B, and when I derive by B, I have B plus. This is B plus, not B star, so I don't split. A B star derive by B. This just means remove the first B, and B plus is B star. So I told you that B plus is equal to B star. So when I say slash B, I cut off this and I remain with B star. So this one we are going to remain with B star A B star. And since this is not the same as this, you see, so this is going to become S1. Now let's come to S1. Now S1 slash A, we have, now you see this is B star. So if it is B star, then you must split. So we're going to have B star slash A star, then the remaining of it, which is A B star. Since I'm splitting, I say plus the remaining, which is A into A B star slash A. Now, the what B's I have A, so that's useless, so I get this, and I'm joining it with this remaining part here. Then I say plus. Now, slash A means remove the first A. When I remove the first A, I'm going to get what? I'm going to get AB. And this one, just this and anything gives me that. That is plus AB star. Now, AB, have you seen AB star anywhere? No. This is S0 is all of this. S1 is all of this. Now, this one I'm going to say now, I'm going to say AB star is going to equal to, let me call it S2. See? Now let me come to S1, derive it by B. What is S1? It is this one. See? So this is B, it is B star, so I must split it. So I say B star slash B, then the remaining part of it, which is AB star, then plus this remaining part, which is now AB star slash B. So you see, this is B star B, but B star means any number of B's. If I have any number of B's and I remove one B, I remain with any number of B's. So I keep my B star, then bring this back. This plus, now this one is starting with A. They're telling that you remove the first B. There's no B here, so you get this. So this one is becoming AB star. Are we seeing it here? B star A is here, so which means this is the same as S1. Now S1 is okay. Now let's go to S2. Now I'm using only A and B because when you see this string here, this one, we only have A and B, you see. But if we add like A, B, and C, then I could be saying S0 slash A, S0 slash B, and S0 slash C. But now we have only two, so I'm going to be using only two, S1 slash A and S1 slash B. Oh boy. Now let's come to S2 now. S2 slash A. Now what is S2? S2 is this boy here. See, S2 is stupid simple, and this is a star. So it is this. You get AB star slash slash A, then plus the remaining, which is what? Epsilon, because this is a star, you must always split, plus, now, what is interesting is what is the remaining part here? It is epsilon, so I bring epsilon slash slash A. Now, when you see this guy here, it is AB. When you have many number of ABs and remove one A, the first A will remain with, because from the first AB we're going to remove A, so we remain with a B. Then we follow it by any number of ABs that come after. See? Then when I put epsilon, it is the same. But epsilon and anything, it is what? It's empty. So I come and get. Did we see it anywhere? No, we haven't seen it anywhere. So this is S. This is S. That is S3. You see? Good. Now let us try to get S2. Now we now have S2 slash slash B. This was A. So S2 slash slash B. First of all, S2 is what? Is AB star. So it's going to be AB star slash slash B epsilon. I'm splitting because this is a star. Then I take the remaining part, which is epsilon slash slash B. Now you see, this one is saying AB star, but we must already start with A, so we can never start with B. You see? So this one is going to give me empty because ABs must always start with A's, but they're telling me to cut the first B, which is impossible. So I get that plus, whenever you see epsilon here, slash slash anything, you just get back that. So this is no state. But we got S3, so you must also derive for S3. So S3 is stroke A. S3 is B, not B star. So no need to split it. If it is B or B plus, don't split. If it is B star, you can split. This slash slash A, it starts with B. I'm saying I must cut the first A. That is impossible. See? Then I come to S3 B. So it is S3 is B, AB star slash slash B. Cut the first B. Yeah, it is possible. I get back AB star. But AB star is already S2. We have it. So I said this is S2. Now we have defined all the S's. S1 is defined, S2 is defined, and the S3 is here. So what is next? The next thing is to draw the automaton. So I'm going to say S0 is my initial state. When I come here on S0, when I see A, I don't go anywhere because you can see from the expression, we cannot start with A, so we cannot go anywhere. When I see a B, I go to S1. So I can say, when I see a B, I go to S1. Good. Now I can say, this is okay now. Let's come to S1. S1, when I see A, I go to S2. S1, when I see A, let me put S2 around here. When I see A, I go to S2. When I see a B, I go to S1. So when I see B, I just loop back. I get it because it's even B plus. So B and any number of B's. It makes sense. This is S1. Now what about S2? S2, when I see A, I go to S3. So you have S3 somewhere. So when I'm in S2 and I see A, I go to S3. And when I'm in S2, this one here, and I see a B, I go to nothing. Now let's come to S3. S3, when you see A, nothing. When you see B, you go to S2. So when you see B, you're coming here. You see, now you may ask me, what are the final states? Now, this method, I'm not very good at it, but I can find the final states from here. See? Let's come to this expression. What is the simplest string in this expression? If all of this is 0, you see, it means, now what is the simplest in B plus? It is B. The simplest in A is just A. This one can all be 0, so it means the simplest string in this language here is BA. So let's come and see, B and A must be accepting. I'm sorry, I forgot this in the first exo, but you can also use the same technique. You come and see this expression, so you come and see what is the simplest string in B plus, it is B. The simplest in A, it is A. Now, AB, we can remove all of it because it is star, so the simplest is B. So the simplest string must be accepting. So when you see a B and A, it must be accepting. You get it? And what is happening is that any number of ABs should also be in the string. So when I see AB, AB1, AB2, AB3. So this is the accepting set. It is only 1. See? Very stupid, simple. You can find the accepting sets using this technique. You just come and see the string and you see the simplest string, then that must give you the accepting state. You're going to be, you can use your intuition to solve these questions. Now, this is the automaton, but they asked me that it must be reduced. You see, they told me it must be reduced. So let me try to reduce this guy here. And to reduce him, I'm going to do what? To draw a table. I say A and B, which is this. I come and say my states. I have S0. It is initial. So to read S0, I come and read it from here. S0 on A goes to nothing. You see? Let me say it goes to dead state. Dead. Nothing. I can call nothing anything. I'm calling it D for this case. Dead. On B it goes to S1. See? Now what about S1? S1 on A it goes to S2. And on B it goes to S1. What about S2? On A it goes to S3, and on B it is going to dead state, and we have S3 now. S3 on A it goes to dead state, and on B it goes to S2. You see? So we can try to reduce this and see what happens. So what I'm going to do, I'm going to reduce it using that algorithm, the beta. So I say beta of 0. Beta of 0, I'm going to get now. You see what is accepting? It is S2. So beta of 0, I'm going to group them into two groups, the accepting and the non-accepting. So the non-accepting, we have S0, we have S1, and we have S3. The accepting, we have S2. So for beta 1, I'm going to write S0, you see? Then I come and read it from here. So S0 and S1. S0 and S1. Sorry, I forgot something here. There is D. Because when I have D, I must also define D. Dead end. For D, whatever comes in does not leave it. So A goes into D and B goes into D. So there is D around here. Because D is not accepting, so I must add it here. So S0 and S1. On A, S0 goes to D, S1 goes to S2. So let me ask you, is D and S2 in the same bracket? They are not, because S2 is here and D is here. So S0 and S1, they separate. I make a new bracket. S0 and S3. S0 and S3. On A, they go to D, that is okay. On B, they go to S1 and S2. But S1 is here, S2 is here, so they're also separating. But I must now compare S3 and S1 to see if they are the same. So S3 and S1. On A, it goes to S2 and D, but S2 is here, D is here. So I can come and say S1 is alone. This S3 is not equal to this and is not equal to this because they separate. We have that, you see? Now, let's come and see this D here. S0 and D. S0 and D. On A they go to D, that's okay. And on B they go to S1, D. S1 and D are in the same bracket, so they are the same. I cross this, and I have my S2. You see? Now let me reduce again. B2. I write my S0. So S0 and D, are they still the same now? S0 and D. On A they go to D, that is okay. On B they go to S1 and D. S1 is here, D is here, so they're not the same anymore, so they separate. That is D, that is S1, S3, and S2. So this automaton was already reduced, so this is the automaton we want. This is, now you see, they're now separating, you see? So which means this automaton was already reduced. So this is the automaton they wanted. We use this method here.